Hello guys, in this video we'll be discussing the question create maximum number Leetcode 321. This is a hard problem. Let's directly dive into the problem. We are given two integer arrays nums1 and nums2 of length m and n respectively. Nums1 and nums2 represents the digits of two numbers. We are also given an integer k. Create the maximum number of length k, that is k is constrained, right? K can be less than or equal to m plus n from the digits of the two numbers. The relative order of the digits from the same array must be preserved. Return an array of the k digits representing the answer. I hope you guys must have gone through the problem statement once on your own, and after that we'll jump on to the solution. Uh, let's see the very first test case. What do we have? We have 3, 4, 6 and 5, and the other array is 9, 1, 2, 5, 8, 3. So let's write that as well. This is 9, 1, 2, 5, 8, 3, and k is given as 5. Let's understand the problem once again. M is the size of this array, that is nums1 array, that is 4. N is the size of the second array, nums2, that is 6. What do we need to do? We need to pick k elements, some elements from nums1, some elements from nums2, and then merge both of these elements to create a final number of size k, that is 5, and we need to maximize the final number created. Let's say I pick the digits d1 and d2 from the first array, and the digits, let's call them x1, x2 and x3 from the second array. Now I can merge these two numbers, that is I can somewhere place d1 and at some another position place d2, but I need to make sure that d1 always comes before d2. Similarly, at some position I can place x1 at some other position, x2 at some another position, x3, but I need to make sure that x1 comes before x2 and x2 comes before x3. This is what means preserving the relative order of the digits from the same array. Now we have got a very clear understanding of the question. Let's just see once the constraints. M and n can be 500, and similarly k, that is obvious, pretty obvious that the size of k would be bounded by the value of m plus n. Before directly diving into the question, let's just break this problem. Let me ask another problem. What if, what if, what if you were given a single array? Let's say this is the array 9, 1, 2, 5, 8, 3. Now here I'll use two terms, that is array and number, interchangeably. So just don't bother with that. And if you are given an integer, let's call it 4. So what you need to do is you need to pick exactly 4 digits from this array and then create the maximum possible number. Like, how can you do that? You can pick 9, 1, 2, 5. This could be one possibility. You can pick 9, 1, 2, 8. This could be another possibility. You can pick 1, 2, 5, 8. Then you can pick something like 1, 5, 8, 3, and then you can just go on. So there can be multiple possible cases. So let's say if the array has a length of n and you need to pick k elements. So there could be nck combinations, right? So the brute force approach to do this is to find all the nck combinations, and then you need to go through all of these arrays and check which is the maximum array, that is the maximum number. So I guess it is very clear that this solution involving nck complexity won't work out. So what's the optimal way to do this? I won't spend a lot of time here because this is a very standard question which can be solved using the concept of monotonic stack. We'll just very quickly move through how to solve this question. What was the array 9, 1, 2, 5, 8, 3? I'll just copy it here once again. The array was 9, 1, 2, 5, 8 and 3. What I can do? I can use the concept of stack here. Let's try it out. I'll first push the element into the stack. That is, I'll push 9 into the stack. The stack is empty. Now, what is the next element? The next element is 1. Is 9 is 1 lesser than or equal to the topmost element of stack? That is the question. Yes, it is. I'll simply push it again. Now the next element is 2. Let's see. 9 1, and is 2 smaller than this? No. So I need to pop this out and then again check whether 2 is smaller than or greater than 9. It is smaller than, right? So I can directly push it. Now the question is, what am I exactly doing? Why am I popping out elements? Let's see. The stack was something like 9 1, and the next element. What does this 9 1 signify? This signifies some kind of number which has the leftmost digit as 9, then 1, and then followed by some digits which we'll create. Now we got a digit 2. What can be the possibility? I could have directly inserted 2. So the number would be something like 9 1 2 and then some more digits. I don't know. And the other possibility could have been is I could have popped out this one and then placed the 2. So the number would be 9 2 and then followed by some more digits. So what we can see, this number, the second number, is greater, right? Why is this greater? Because this digit 2, which is the larger digit, has been placed at a more significant bit position, right? The bit position is not the very right word to use it, but just for the lack of better vocabulary, I'm using the bit position. So the larger digit should be placed at a bit position which has higher significance. That is the reason I placed 2 at this position. And how did I decide? Because 1 was smaller than this. So it's pretty obvious, right? 2 should be placed before 1. That's what I did. I simply popped out 1 and then pushed 2. So what is the current stack looking as? 9 and 2, right? Now, should I pop out 3 and place 2 in place of 3? Like, would that make sense? No, right? Because the number is 9 2, right? And if I pop out this and place it here, so the number would be 2 and then something. So which is greater, a number starting with 9 and a number starting with 2? It's pretty obvious, right? A number starting with 9 has more value, so I won't do that. So the current stack is 9 2. After 9 2, the next element is 5. Again the same thing. 5 is greater than 2, just pop out 2 and place 5. Now 5 is not greater than 9, right? So I did not pop it out. The next element is 8. Is 8 greater than 5? Yes. So ideally what should I do? I should pop out 5 and place 8 there, right? This is what we have discussed till now. Now comes the twist. We need to make sure that at the end we have at least k digits, right? So if I pop out this 5 and let's assume that I place all of these digits, right? All of these digits. So how many digits are remaining? We just have 2 digits remaining, right? So if I would have popped out 5, so we would have a 9 and then 2 more digits. So the total count of digits would be 3. But we need to make sure that k is 4. That is, we need to have what? How many digits? 4 digits. So I cannot pop out 5, right? I hope this makes sense. Although 8 is greater than 5, but just because we need to create a number which has k digits, so I'm not popping out 5 here. So I'll simply place 8 and then again I'll simply place 3 because we need to have at least k digits. So what was the time complexity to do this? To achieve this, the time complexity was I was traversing through the entire array once, right? And the popping operations and the pushing operations are constant time operations, so the time complexity was big O of n. You can comment down the space complexity. Now let's write a pseudocode for this. How would the pseudocode look like? I would travel through the entire array, right? That is what I was doing. I was traversing through the entire array. Let's traverse I is equal to 0 till n. Now what would I do? I'll just write a while loop here. I need to check multiple conditions. The first condition was that is the stack should not be empty, right? If the stack is empty, I'll directly push the element. But if the stack is not empty, I'll make some checks. Let's just go through the checks. The first check is stack should not be empty. The second check is the topmost element of stack. What it should be, the topmost element of the stack. If the topmost element of the stack, if that is lesser than what the current element, that is nums of I, right? And then there was this third condition. Third condition was that we need to have at least k digits. So how would I ensure this? Let me just write this as of now. I'll explain it in a few minutes. That is stack.size minus 1. Why is this stack.size minus 1? If I'll pop out an element, the size of the stack would be reduced by 1. That is stack.size minus 1. And how many more elements are remaining? N minus I elements are remaining. So after popping out one element and considering that I would insert all of the following elements into the stack, the maximum size of stack would be stack.size minus 1 plus n minus I. Now this should be greater than equal to k. Let me write it. This should be greater than equal to k. If all of these conditions hold, I'll just simply go and pop out the topmost element. That's what I was doing. After that, once it comes out of this while loop, I'll simply go and push the element into the stack. That is stack.push nums of I. I hope this makes sense, right? And then this while loop closes. So this is the pseudocode. This is the pseudocode for the case when we are given an array nums of size n and an integer k such that k is less than or equal to n. That is, we need to pick out k elements from this array and create the maximum possible number. A time complexity to do this is big O of n. This is the very first step. Now comes the second part of the question. Now comes dividing the questions into sub-problems which relates to what we have already studied. And let's see it out. Let's say I would pick x elements from nums1 array and y elements from nums2 array. So what is the case? This x plus y should be equal to k, right? Let's assume, let's take it here. If k is equal to 5, so I can pick 2 elements from the first array and 3 elements from the second array. This could be a scenario, right? Such that 2 plus 3 is equals to 5. And the other thing which we need to ensure is this x must be less than equal to m. What is m? M is nums1.size. Acha, this m and n notations, what I'm using here might not be exactly same what I'll use in the code, so I'll explain the code separately. And y should be less than equal to n, so what is n? N is nums2.size. So yeah, these three conditions are possible. I can pick x elements from nums1, y elements from nums2 such that both of these sum to k. Now, to pick x elements from nums1 in a way such that I create the maximum possible number. That is what we have discussed here, right? I can also pick y and create the maximum possible number. That is what we have discussed previously, right? We can use monotonic stack for that. Okay. So let's say after picking x element from nums1, the array or the number which I have got is temp1. Let's call it temp1. And after picking y elements from nums2, the maximum possible number which we can get is temp2. So the number of digits in temp1 plus the number of digits in temp2, their sum equals k. This is what we are assuming. Now the next step is what? We need to return a single number, right? We don't need to return two numbers, temp1 and temp2. We need to somehow merge these two numbers and create the final number temp. And this temp needs to be maximized. So what is the problem? The problem is to merge. We need to merge. What do we need to merge? Temp1 and temp2. Got it. So how do we merge these two numbers? Let me give a very simple example. Here would be three cases. I'll start with a very basic case. Let's take very less elements. Let's just take 3 elements, 8, 5 and let's say 9. Let's take other array which has just 2 elements, 2 and 7. So how would you merge these two arrays keeping the relative order same? Let's keep a pointer I here, let's keep a pointer j here. So the final merged array would look something like this here. Acha, what would you pick? 8 or 2? I guess to create or to maximize the array, that is maximize the merged number, I would pick larger elements in the front. So I would first pick 8. I guess it's pretty obvious. Increment I. What would you pick? 5 or 2? 5 is greater, pick 5. What would you pick? 9 or 2? Pretty obvious. 9 is greater, pick 9. Now this array is exhausted. So what are the remaining elements? Just go and simply push them, 2 and 7. So I guess you've got idea, right? We need to pick the maximum element. Just note it down once. This is the writing is pretty bad. I'll try to write better. The case one. If nums1 of I is greater than nums2 of j, what do we need to do? What did we do? Pick nums1 of I, right, and then increment I. This is what we have done. Case 2, exactly opposite of this case. If nums1 of I is less than nums2 of j, right, what do we do? Pick element from nums2 of j, and then simply increment j. Okay, just a second. Is this solution complete, or is there any more case? Yeah, you guessed it right. There is one more case. I guess most of you would have guessed it till now. What if the two elements are equal? That is nums1. Uh, this should not be nums1, right? This should be temp1. This should be temp2. This should be temp1. My bad. Again, this should be temp1. This should be temp2. This should be temp. My bad. The concept still remains the same. Why temp? Because here we have assumed that the two numbers would be called temp1 and temp2. Just for the sake of keeping the naming consistency, I'm doing this. This again would not be nums. This would be temp, right? Don't confuse with nums and temp. This is just for the sake of naming. If temp1 of I and temp2 of j, right? Temp2 of j. What if these two elements are equal? Okay, this is an interesting case. Let's see. What would you do? I'll just try to explain this very easily. Let's say this is 2, 2, 2, and then 3. Let's say this is again 2, 2, 2, and then 4, and let's put some more elements. 5, 6, 7, 8. Hope this works. Okay. So I is here, j is here, both of these elements are equal, increment. Again, both of these elements are equal, increment. Again, both of these elements are equal, increment. Again, both of these elements are equal. Okay, no, they are not equal. We found a case where I and j, that is the elements present at temp1 of I and temp2 of j, are not equal. What do we need to do? We need to pick this 4 first, right? Like, not exactly first. We need to pick this 4 before this 3. Now, to pick this 4 before these 3, we need to first exhaust these elements, right? If first these elements are exhausted, how would the array look like? If we exhaust the elements from temp1, the array would something look like 3, 5, 6 and 2, 2, 2, 4, 7, 8. So comparing 3 with 2, you would pick 3. But what? What if we would have picked these three 2s? So at the similar bit position, we could have placed a larger digit, right? 4. But here we are placing 3. I hope this makes sense. Just try to dry run it once. So yeah, at the first point of inequality, whichever of these temp1 or temp2 has greater element, just pick the very first element of that particular array. Here we'll pick the element from temp2 array. I hope this makes sense. There could be some more cases. Let's just explore through them as well very quickly. 2, 2, 2 and 2, 2, 2 and 3. I here, j here, increment, I here, j here, again increment, I here, j here, again increment, I here, j here. Temp1 is exhausted, temp2 still has some elements left. Just pick the first element of temp2. Again, the similar logic, what I've explained here, right? Just dry run it once, you'll get an idea. Okay, so we've also what do we need to do in this particular case, right? When both of these elements are equal, I'll write it again separately. Case 3 is equality case. So what did we do? We first find find first index with unequal entries or unequal digits, and then whichever has larger digit, pick the element from that particular array. It would be more clear when we try to code this out. I'll not write pseudocode for this. That would be very long and exactly same as the original code. So that's it. That's it, guys. We have got a solution. What did we do? We took an x, we took an y. From x we generated number temp1, from y we generated number temp2, and then we merged both of these numbers to find temp. Now the question is, ah, what are the suitable values? What are the most appropriate values of x and y? Right? Let's just see this. What can be the possible values of x and y? Let's write it down here. Let's say k is 5. So x can be 0, y can be 5, x can be 1, y can be 4, all the way up to x can be 5 and y can be 0. So how do I know which is the best combination, right? Is there any way, is there any algorithm? Just try it out once on your own. What you would see is there's no particular rule for picking out x and y, right? What do we need to do? We need to check for all possible values of x and y. Simply just brute through this. Check for all possible values of x comma y. For all of these values, you would generate multiple temp values. Temp, 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 right? That is for x0, y1, there would be one temp value, right? x0, y5. For x1, y4, I would generate another possible value. For x2, y3, I would generate another possible value. All the way up to x5, y0, I'll generate another possible value. What do I need to do? Out of all these, pick the maximum value. Okay? Pick the maximum value. Now, once you have picked this maximum value, return this as your answer. This is your final answer. Ah. So the problem is solved. How? Just go through it once again. Split it out into x and y. Pick x elements from nums1, y elements from nums2. While picking x elements from nums1, make sure to make the largest possible number. Similarly, make sure to make the largest possible number. Let's call these two numbers temp1 and temp2. Merge temp1 and temp2 to generate temp. Now, out of all of these multiple possible values of temp, just pick out the maximum possible value and return it as your answer. Let's very quickly go through the code once. Okay, let's start with this function of monotonic stack. If we are given a single array, let's call it nums, and an integer k, that is we need to pick k elements from the nums array such that we need to generate the maximum possible value. Pretty simple. N is nums dot size. If k is greater than n, that is I cannot pick k elements. The size of the array is less than k. Simply return an empty array. Otherwise, what you need to do, you need to create the stack. This is the answer stack. Instead of creating a stack, I am directly creating a vector. So the pushback and popback operations in a vector would exactly simulate what a stack does. Just otherwise you could have created a stack. I'm not. Answer.pushback nums of 0, because originally the stack is empty. Simply push back the first element, then traverse through the array. This is the condition. The array should not be empty. Nums of I should be greater than answer.back, that is stack.top, that is the top. And answer.size -1 plus n minus I should be greater than equal to k. I've already explained this before. Why do we need to impose this condition? Just to make sure that at the very end in the stack we have at least k elements. If all of these elements conditions satisfy, we'll just pop out the topmost element and then pop in. There's no such word as pop in, very sorry. We'll just push the element as index I, that is nums of I. After that, there could be a case where the stack has a size greater than k, so just pop out the last few elements of the stack and make sure that the stack has a size of only up to k. That is, while is greater than k, I'll make sure to pop back elements, that is answer dot pop back, and then finally return the answer. Now, how would this merge logic work? So for this merge logic, what do we have? We have these two arrays, right? V1 and V2. So what is V1 and V2? What we have discussed was temp1 and temp2, right? So temp1 corresponds to V1 and temp2 corresponds to V2 for this particular function. I hope this makes sense. So the size of V1 is m, the size of V2 is n. We use two iterators I and j. I have already shown, while I less than m and j less than n, that is, we have not exhausted both of these arrays. We will check. What we'll check? We'll check whether these two elements are equal. That is the case 3 first. So I'll create two more iterators, temp I and temp j, initialize them to I and j respectively, and they'll traverse through the array. We're trying to find the first point of inequality, that is, while temp I is less than m and temp j is less than n, and both of these elements at index temp I of v1 and at index temp j of v2, both of these digits are equal, so it simply increment those pointers. Once we come out of this loop, the very first condition I'm checking is whether did we exhaust the second array, that is v2 array. So if temp j is equal n, that means we have exhausted the second array. So if we have exhausted the second array, we should pick element from the first array, that is v1. So what I'll do, I'll pick that element from v1, that is answer dot pushback v of I, because at what index were we before this? We were at index I and j, right? And the element at index I and j was equal. For that reason, we use two more iterators, temp I and temp j. So after the while loop, temp I and temp j does not have any significance, right? We need to pick element either at index I or at index j. So that's why I'm picking element at index I, that is v1 of I, and incrementing I. Similarly, I'll check if the first array has exhausted. The first array has exhausted, pick the element at jth index array and increment j. Now, if neither of these two arrays have exhausted, so we'll check which array has the larger element at the first point of inequality. If v1 has larger element, if v1 of temp I is greater than v2 of temp j, simply pick the element at ith index of v1, increment I, and in the other case, pick the element at jth index of v2 and increment j. So that was the very first case where v1 of I was equal to v2 of j. The next two cases are pretty simple. If v1 of I is greater than v2 of j, pick the element at ith index of v1, that is answer dot pushback v1 of I and increment I. Otherwise, pick the element at jth index of v2, answer dot pushback v2 of j and j plus plus. I hope this makes sense. Now, what could happen? There could be a case where we have exhausted either v1 or v2. So some elements might be remaining in v1 or v2. Just simply pick all of those elements and insert into the final merged number. That is, while I less than n, simply pick the element at index I, increment I, do this till you have exhausted the first array, or you have exhausted. If you have elements in the second array, just exhaust that as well. Acha, just think once that either this while loop will execute or this while loop will execute. There could not be any scenario where both of these while loops will execute. Just dry run it once, you'll get a better understanding. Now the main function, that is the max number function. So we'll do numbers nums1 and nums2 and an integer k, right? We'll create the final array answer which we need to return. So we'll go through this I0, I less than equal to k, I plus plus. That is, the value of I here signifies x. So what is y? K minus I is y. I hope this makes sense. Just see this. So we'll create this number temp1. You got it, right? We will pick x elements, that is I element from nums1 array. That is this, I'll call this solve function. This solve function was the monotonic stack function. Passing I and nums1, I'll call this temp2. Passing k minus I and nums2, I need to then merge temp1 and temp2, so I'll call this merge function which would merge temp1 and temp2 and give me the final temp. I just need to check if temp.size is equal k. Just need to like include this temp in my answer, so answer would be maximum of answer comma temp, and then finally return the answer. So I hope this solution makes sense. Let's just again once go through the solution. What did we first do? Initially we were given two arrays. I thought if we would have been given a single array, would I be able to solve that question? Oh yes, I was able to solve that question. How? Using a monotonic stack was the most optimized approach. Then this was the pseudocode for monotonic stack. Then what did I do? I assumed, okay, I'll have some x elements from the first array, y elements from the second array, such that both of these sum up to k. How to solve that problem? Again, for picking x elements and y elements from nums1 and nums2 respectively to generate the maximum possible number, we would again use monotonic stack. And then from these two possible generations, that is temp1 and temp2, I would again merge them. This is the merging logic. And what could be the optimal values for x and y? We did root through all the possible values of x and y. We got multiple temp values and maximized those temp values and returned the maximum possible of all of those temp values. So yeah, this was a pretty easy question. The important point here is how did I approach the question? To approach the question, I tried to map it to a question which I had previously solved, that is the monotonic stack problem. Then try to break down the current problem into multiple sub-problems, related it to the previously solved problem, got an inspiration from that solution, and then try to build the solution. So this is how you need to approach new problems, and particularly hard problems. These hard problems are nothing just but some kind of variations of previously solved problems. Merging all of those concepts which you would have already come across would help you solve these new problems. Okay, so thank you. That's all for this video.